Okay. Hi, team. Thank you for coming to our EpiCentre seminar series. I guess this is our seventh presentation and probably the last one of this year. Today's speaker is Emily. Emily is from Canada and is a massive vet school student, just finished her second year. She has a degree in marine biology from the University of Victoria, where she's participated in research studies about the effects of climate change on ocean ecosystems. She is now combining her previous experience and vet medicine by investigating the effects of climate change on the incidence of leptospirosis in livestock. Following Cyclone Gabrielle in February 2023, a noticeable surge in leptospirosis cases among humans in New Zealand prompted to explore a potential correlation in livestock. She is currently investigating the impact of climate-related factors, specifically increased rainfall and flooding, on the likelihood of leptospirosis incidence in sheep and cattle. Emily, stage is yours.
Thank you so much for the introduction. Hi, my name is Emily, and today I'm going to be talking to you about the effects of climate change on incidence of leptospirosis in livestock in New Zealand. I just finished my second year at Massey, and my project is supervised by Dr. Masako Ueda and Dr. Emily Bailey, and we've been working with Jonathan Watts from MPI. So our interest for this project was piqued by the surge in climate extremes in New Zealand at the start of 2023. Auckland faced floods in January, and the North Island was devastated by the effects of Cyclone Gabrielle in early February. These events caused increased flooding and surface runoff, which created a breeding ground for potential bacteria. Many livestock diseases in New Zealand are climate sensitive, and we suspect that the compounding effects of the warm and wet summers will have a significant impact on animal health. Leptospirosis is one bacteria in particular that persists in wet and moist environments. And these environments increase the risk of transmission through contaminated water and soil, as lepto is able to survive in soils and can be resuspended during rain events. Since Cyclone Gabrielle hit, there has been a surge in human leptospirosis cases, especially in the Hawke's Bay region, which was heavily affected by the storm. Human infection is a strong indicator that the disease is already present in livestock populations, and we wanted to see if this was reflected in the data. So our objectives for this study were to determine if the incidence of laboratory-diagnosed leptospirosis cases in livestock in New Zealand increases after severe weather events. We wanted to describe the spatio-temporal patterns in leptospirosis incidence in sheep and cattle, to find climactic factors that were associated with an increase in leptospirosis outbreaks, and to determine if there was a difference between incidence in sheep and cattle after these climate events. So we used two sources for our data collection, one for disease data in livestock and the other for our climate data. The disease data was sourced from MPI laboratory submission data for sheep and cattle between the years 2011 and 2023. We only included cases with a confirmed diagnosis for leptospirosis. The total cases diagnosed between these years were 148 cases for sheep and 220 cases for cattle. We then counted the cases by district, by season, and by year, and noted any trends. The climate data was sourced from NIWA Daily Virtual Climate Station Network, which collects data approximately every 5 kilometers across New Zealand. Since lepto is primarily transmitted through contaminated water and soil, we chose variables we thought would increase these risk factors. So the variables that we chose were seasonal mean rainfall, which is calculated as millimeters of rainfall per day averaged across each 3-month season, the frequency of extreme rainfall, which we use to measure flooding events, and this is calculated as any time there was greater than 100 millimeters of rain within 24 hours. And we chose 100 millimeters of rain as this is the threshold that NIWA uses to describe any flooding event. We used mean soil moisture deficit, which is the average difference between how much water is actually in the soil and how much water the soil can hold, and the frequency of surface runoff, which is defined as any time the soil moisture deficit is greater than 0 millimeters, as this would be when water is pooling at the surface. You can see in the graphs that these two variables are correlated, but the soil moisture deficit is impacted by other variables like temperature as well. And this map in the top corner shows the rainfall levels on February 13th, 2023, which is the day Cyclone Gabriel hit. And the red areas show areas of extreme rainfall. And as you can see, the north and east of the North Island were the most severely affected, particularly the Hawke's Bay region. So for our descriptive analysis, we used R and NPI's Early Aberration Reporting System, EARS. And for our data analysis, we used chi-squared tests and mixed effect Poisson regression models. For the chi-squared tests, we tested the association between the presence of lepto cases and flooding and runoff indices. We tested each district individually, and for the presence of lepto, we combined 2 consecutive seasons. For example, if we were looking at a climate event that occurred in the spring, we looked at lepto cases that occurred that spring and the following summer. And we did this in an attempt to account for the lag between climate events, the environmental contamination, the animal actually getting infected, and the laboratory diagnosis, as this process can take several months for the cases to show up in our data. And for the mixed effect Poisson regression models, we tested the effects of each climate indices on lepto case counts, combining again the 2 consecutive seasons. We used district as a random effect and accounted for underlying differences by season, population size, and North and South Islands. So this is an aberration report using weekly case counts of MPI laboratory submissions for sheep that were found dead in 2023. So this data represents all of sheep mortality in New Zealand in 2023, with sheep that died from any cause, not just leptospirosis. This black line represents the observed case counts for this year, and the colored lines represent the threshold of aberration for 5 different algorithms. The bottom line is comparing this year to the historical average, with red representing the highest aberration level. Now, the aberration happened repeatedly in the first half of 2023 and was detected by multiple algorithms. So this shows that sheep mortality has exceeded the expected threshold for this year. This is the annual confirmed leptospirosis cases in New Zealand sheep and cattle between the years 2011 and 2023. And the year 2023 contains data from January until October. As you can see, the annual case count for sheep in 2023 matches the highest annual case count ever reported in sheep. And the cases in 2023 are 2.5 times greater than the average. The peaks in 2023 and 2017 both coincide with cyclones, Cyclone Gabriel in February 2023 and Cyclone Cook in April 2017. Our cattle data, which includes both beef and dairy cattle, also showed an increase of cases in 2017. However, it did not show the same increase as sheep in 2023. The case counts for cattle this year are actually slightly below average. And our hypothesis for this is based on the presenting signs. For sheep, the primary presenting signs are found dead and urinary disease, whereas for cattle, it is much more common for them to present with abortion, stillbirth, and abnormalities of the reproductive tract. The signs for sheep can be shown all year round. However, the presenting signs for cattle are likely only to be noticed later in their reproductive season. The cases for cattle in 2017 were almost all found between the months of June to August, which is their calving season. This is only a few months after Cyclone Cook hit in April. We suspect that Cyclone Gabriel in 2023 was too early in the season to show clinical signs in cattle. So these maps represent the incidence rate of confirmed leptospirosis cases per district between the months of January and October in 2023. The data is reflected as cases per 1,000 farms. The incidence rate in sheep in 2023 is higher than in cattle. However, the regions with the highest incidence rate are similar for both species. These areas are the north and east of the North Island, which are the same regions that were affected by climate events in 2023. The incidence rates only include cases with a confirmed diagnosis for leptospirosis. This does not include any untested, unreported, or undiagnosed cases. And that is the major limitation to using passive surveillance. So in order to get our data set for our analysis, A series of events must occur in order. First, the animal must get infected, and then the animal must start to show clinical signs. This excludes all subclinical cases. Then, the farmer must detect the clinical signs and notice that something is abnormal. Once noticing this, the farmer must decide it is worth reporting to the vet. And there are many potential reasons a farmer may choose not to report a case, for example, if it is an isolated case or they are financially constrained. Once reported, the vet must decide to request diagnostic tests and then request the correct diagnostic test. And then finally, the diagnostic test must be sensitive enough to confirm a diagnosis. And these cases with a confirmed diagnosis are the only cases used in our analysis thus far. So we performed a chi-squared test on each region and individual district and found that in Central Hawke's Bay, there was a positive association between seasonal mean rainfall and sheep leptospirosis recording. We used 2 consecutive seasons to look for the presence and absence of lepto, and the threshold of low to high rainfall was based on the historical mean. As you can see, when rainfall was low, lepto was more often absent, and when rainfall was high, it was more likely to be present. When seasonal mean rainfall was high in Central Hawke's Bay, the risk of leptospirosis reporting was 2.2 times higher compared to a low rainfall season. This was the only variable, however, to show an association. There was no effect with extreme rainfall, no effect of surface runoff or soil moisture deficit. None of the other districts showed a significant association, and cattle in Central Hawke's Bay did not show an association. So this led us to use our Poisson mixed effect models. For these models, we estimated the incidence risk ratio of climate indices on the 2-season combined number of lepto cases, accounting for confounding variables such as season, number of farms, North versus South Island, and using district as a random effect. This result shows that in sheep, an increase in the frequency of extreme rainfall by 1 day per season is associated with an increase in confirmed leptospirosis cases by 461% across the next 2 seasons. There's a 26% increase due to seasonal mean rainfall, a 9% increase due to surface runoff, and 3% due to soil moisture deficit. In cattle, there is no significant increase in leptospirosis cases following any rainfall events. There is, however, a 5% increase in lepto cases following increased surface runoff and 1% increase following soil moisture deficit. Some factors that may have influenced our results include data robustness, our confounding variables, and the lag between climate events and diagnosed cases. For the data, the diagnosed case counts used in the analysis do not include any untested, unreported, or undiagnosed cases, meaning the actual magnitude of the outbreaks would be higher. Most farm vets would be able to perform postmortems on site, and given that leptospirosis in sheep causes significant changes to the body, it is likely that the vets would be able to confirm their suspicion on site and not require any additional diagnostic testing. Additionally, the climate data may not capture all of the effects and is not specific to the farm area. Our confounding variables included were season, population size, and North versus South Island. The regression models we used successfully accounted for these variables, however, the chi-square test could not. Furthermore, there's likely a lag between climate effects and diagnosed cases due to the time delay between climate events, environmental contamination, animal infection, and laboratory diagnosis, and we combined case counts in 2 seasons to try to account for this. To summarize, the extreme rainfall, mean rainfall, and surface runoff were suggested as potential risk factors for sheep leptospirosis. Cattle leptospirosis was positively associated with surface runoff, but was resistant to rainfall events. And the findings could be used to improve leptospirosis preparedness for livestock and public health in the face of future climate change. I would like to acknowledge our funding from the School of Veterinary Science at Massey University, and a special thank you to John Watts from MPI and Abda Sood from NIWA for supplying the data for our analysis. And thank you again to my supervisors, Dr. Masako Ueda and Dr. Emile Bailey, for supporting me throughout this project. And thank you, and let me know if you have any questions.
Thank you, Emily. It was really amazing presentation.
Thank you.
Is there any questions? Oh, Julie?
Yeah, thank you for that. Really enjoyed that presentation, Emily. I'm just wondering I'm quite interested in the difference between the cattle and the sheep. And I was wondering, not knowing, heaps about farming, but are the sheep more likely to be on hilly sort of situations and cattle more on flatter situations? And as a consequence of the flooding, were proportionally more cattle sent off or out of the Hawke's Bay as opposed to sheep? So could it be that some of the disease in cattle was actually undetected because they were sent out of the Hawke's Bay to the meatworks or what have you? Do you know what the proportions were with the various livestock classes?
That's a great question. So as for their terrain, yes, sheep are definitely more commonly raised on hill country. And one thing with our cattle data is that it's including both dairy and beef cattle. So something we have discussed is potentially in the future separating these two, because beef cattle in New Zealand are commonly actually raised with the sheep on hill country, whereas dairy cattle are more commonly on flat ground. And we think that could be one of the things that has an effect. One of our hypotheses is that potentially the beef cattle would show a similar effect to the sheep, given that they're on the same terrain. And the reason there's no significance could be because the dairy cattle data is kind of skewing that result. But that's definitely something we want to explore further in the future. As for the second part of your question, whether more cattle were sent away to the meatworks and maybe that's why it's unreported, that's a really good point. I'm not actually too sure. But would definitely be something we'd like to look into as a potential reason that it was underreported.
Yeah, and I suppose over in the Hawke's Bay, about 95% or so of the dairy cattle would be vaccinated against those two main strains anyway too, which is also something which would be affecting that. Yeah, okay. Thank you very much for that. Cheers.
No worries. Thank you.
Thank you. And any other questions?
Julie, I have a question.
Go ahead, Chitis.
Thanks, Emily. That was fabulous. A very wonderful presentation. And sorry, I didn't join early part of your presentation, so probably I may have missed. But so I was just curious, when you say the impact of climate change and drivers on the presence of leptospirosis, so did you take into account of the factors such as climate change causing the movement of animals or the wildlife between the islands or between the farms, and also the other factors that that climate change may have, like the temperature, humidity? I mean, I saw the rainfalls and flooding that you have mentioned, but did I miss other factors in this new study?
No, so that's a good question. So we have not gone into any details regarding wildlife movements or other variables such as temperature or humidity. Those are all things that we have discussed as potentially going into further. We chose 4 variables to start with, the mean rainfall and the flooding, as well as the soil variables. So we wanted to keep it narrow to leptospirosis, as it's primarily transmitted from what we know through contaminated soil and pooling water. We know that leptospirosis is also very common in wildlife, particularly rats and things like that. So we would like to see how that affects things as well, but we wanted to start simple, see if we could notice any trends there, and then kind of move on from there. But that's definitely an area that we would like to explore in the future.
Yeah, all the best, Emily. Thanks.
Thank you.
Yeah, question, Emily, and great presentation. Thanks very much. Did you present us any information about the serovars that may have been detected?
So I didn't include it in the presentation, but we did look into which serovars were present, and it was Harjo and Pomona were the 2 primary ones for both sheep and cattle. And then there was 1 or 2 of kind of each of the others, but nothing significant. So those were the 2 main ones.
Great, thank you.
No more questions, I guess. Oh, one for Julie again.
Oh, well, just one comment there. What's really interesting about the Haja and Pomona is that more of the wildlife would be carrying vellum and Copenhagenii, etc. So, you know, it's really quite startling that most of the serovar information that you're getting is from serovars which are circulating through the wild, through the livestock, not the wildlife. Because usually under flooding, you think, oh, all the rats are coming together and the mice are all accumulating together and transferring the lepto to them, but that doesn't seem to be the case. So this is really quite fascinating. Yeah.
Yes, I agree. I also find that very interesting.
Thank you, Julie and Emily. If there's no more question, I guess we can wrap it up. Great. Thank you, Emily, for your great presentation. It was really, really nice. And all the people who joined today, thank you again. And we will probably have our next seminar series in next year. Until then, see you guys later. Bye.
Thank you.